I'm going to introduce you about this final project. I'm going to explain each part, so please pay attention. And whenever you have questions, you may come back to this video to figure it out. Okay, the first of all, please make sure that you read the first part. And it's very important to understand that every element in the periodic table have its unique physical and chemical properties. Those kind of unique properties mainly because the arrangement of the electrons. Okay, and also it has different kinds of protons and neutrons. Okay, so what you're going to do for this project is you're going to do research on one of the elements. I'm going to give each one of you assignment of the first one of the first 20 elements. If you are typically interested in some other elements, feel free to let me know so you can choose any elements from the periodic table. Okay, so first of all, you're going to write the element name. For example, if you got carbon, you just write carbon. That's called element name. Element symbol is the one you can find in the periodic table. So where can you find a periodic table? If you go to Schoology, I have the periodic table posted right below the first file. So it's the second file in Schoology. You may click it. Each time, whenever you need a periodic table, you can click it and use it. And one thing you may do is make sure to save one in your computer or in your chemistry drive, because this is like our tool for chemistry. It's very important to be able to use the periodic table. Okay, so number of protons is basically it's this number. If you're working on hydrogen, number of protons is 1. Lithium, number of protons is 3. Okay, it's labeled in the periodic table. Okay, and number of electrons when it's neutral, which is the same as the number of protons. Number of neutrons, you can calculate it based on the mass number, which you can round it up. For example, this is 6.94, round it up to 7. And the mass number is number of protons plus number of neutrons. So you're going to use 7, subtract the number of protons, which will give you 4. So for lithium, normally lithium have 4 valence neutrons. Sorry. For this one, for beryllium, you can just round it and round it down because it's 0, 1, so it's 9. The mass number is 9, number of protons is 4, so 9 subtract by 4 give you 5. That's how you know the number of neutrons. Okay, and then the second thing you need to do is periodic table square, which is I'm talking about this square. Okay, it's including the symbol, the name, the mass number or the atomic mass, and the number of protons. How are you going to get a square? I would say you can just Google the image of periodic table square of hydrogen. It should come out. Okay, if you're working on magnesium, you just say periodic table square of magnesium. It should come out. Okay, you can copy and paste it into here. And then the atomic number of the element, again, which is this number, the number with decimal points. You don't have to write so many digits. You can just keep 3 digits after the decimal point. Okay, round it up or round it down. That should be good enough. The atomic number is the number of protons, which is the whole number in there. The atomic mass is the one with decimal points. And then the molar mass, which is the same number as the atomic mass, but the unit is grams. Okay, grams per mole. Okay, so these 3 things you can find it in the square. Okay, the unit for atomic mass is AMU. The unit for molar mass is gram per mole, or you can write gram is fine. Okay, and the part F is a bit complicated. I need you to do it on a separate piece of paper. Make a model of an atom of the element. You may use any 3 colors of different objects. to represent protons, neutrons, and electrons. And make sure you put the protons and neutrons right in the center to represent nucleus, and then to put the electrons in the orbits according to the electron arrangement. Like the first energy level can hold 2 electrons, the second can hold 8, and the third one can hold 8 electrons. And once you finish, you can take a picture of your model and copy and paste the picture over here. If you really can't figure out what to use at home, I would say you can use colored markers to draw a model at here. Okay, so here are a few examples from last quarter's class. Of course, those are not the best, but this give you an idea for what to do. Okay, you may use candies, you may use some um, um, what are those stuff? Some beans, cereals, whatever you can find. Okay. Okay. So then the next thing it asks you is number of valence electrons. The valence electrons are the electrons in the most outer energy level. So make sure you know how to determine it. And based on the periodic table, which period does the element belong to? Based on the periodic table, which group does the element belong to? I hope you still remember what does it mean by a period, what does it mean by a group. I would give you an example. For example, if your element is potassium, this vertical column is the group number. So potassium is in group 1 of the periodic table. And this horizontal row is basically period. And the potassium is in period 4. That's how you find the period and the group number. Okay, the next thing is asking you about the physical properties of the element. Please make sure this is talking about the single element. It's not talking about any products of the element. Okay, so state of matter at room temperature, for example, oxygen is a gas, and carbon normally is a solid. Sodium normally is a solid. So what you do is find those information by Google it. Okay, you can type in physical properties of, put your element name in there. It should come out. If there's no color, just say no color. Okay, and if it has no conductivity, just say no conductivity. If it's a good conductor, you just say it's good. So find melting point, boiling point, hardness. If it's a gas, there is no hardness. You can just say not applicable or no hardness. Okay. So this part is, can it form compounds, molecules? If so, write 3 examples of the compounds. Okay, please also identify them as ionic or covalent. Okay, for example, if you are working on magnesium, you're going to write a few compounds of magnesium, like magnesium oxide, magnesium chloride, and then you want to write the type of bond. Okay, if you get neon or argon, which is the noble gas, which is rarely from any compound, you may explain it in here. Okay, and then L is uses of the element or its compounds. You can write the element itself. For example, if you're working on carbon, you can just write the uses of carbon in the real world, and then you can also write carbon dioxide, methane. Those are all carbon products. Please make sure you write the detail of the compounds and where do we use it. Be more specific about the application. Okay, please write at least 5 of those applications. And the last part is for you to do some further research about interesting facts about the elements. Like, hey, this element is the most abundant in the world, or this element is the hardest material in the world, and this element can be found in our bones or teeth. Something that you feel like very interested, or it's rarely known by people. Okay, you can put it in here. That's all for your final project. Have fun with it, and please turn it in by or before this Thursday, which is the last day of school. It's December 17th would be our last day. Please make sure you get it done by the 17th. Okay, thank you. And always please make sure that I'm here to support you whenever you have a question.